Yes, welcome from my side, and thank you for sticking so late to the presentation. I will talk about sEEnergies, which is the project, and with a focus on industrial excess heat and its utilization for district heating. Very short about the project. It is okay. The full title for sEEnergies, the acronym is Quantification of Synergies between Energy Efficiency First Principle and Renewable Energy Systems for 2050 Decarbonization. It's a Horizon 2020 project, and it ended in 2022 with 3 years duration, 5 work packages, and you see in the 9 project partners there. Our part from Fraunhofer ISI, as I said, was the focus on the industry modeling and the industrial excess heats. There were several open data sets published, or numerous. It's worth to check them out. Yes, more general, the methods were energy system modeling on EU level, so really large scale, with several sectoral bottom-up models covering industry, buildings, transport, and they were brought together in a spatial analysis, so high spatial resolution. Yes, and the scope of this presentation will not only be the sEEnergies project, but also a further publication I did afterwards, after the project. There's a typo here, sorry about that. And with both of these publications, there are open data sets, which where you can find the links down there. So first, there's the deliverable of the project, the D5.1 about excess heat potentials, which we published and also in a journal article. And then one step further, we also analyzed low carbon processes and its impact on the excess heat potential in the EU. That being said, I will go to the content now. So these are this is one snippet of the results which are published. So there you can see the industrial excess heat per industrial site, per subsector, and here distinguished by the size of the points, which represent then the excess heat level. And this whole data set you can download as Excel file and spatial data. So they are georeferenced. Yes. The method, short overview, it's a stepwise approach. I will go into each of these steps very shortly in the next slides. So it's covering EU 27 and UK. And as a first step, we constructed the industrial database where we have plant-specific information on the process with coordinates. This we selected then relevant processes and multiplied with excess heat factors for different assumptions, and ended up with 1,600 sites that have excess heat potentials, and we mapped them with district heating areas. And in the end, we can say what's the potential excess heat utilization in current and future district heating networks, so actual and possible district heating. So for the first step, briefly about the industrial database. There, as I said, we have, I think, more than 5,000. I'm sure it's more than 5,000 industrial sites listed. It's based on the EU ETS and the EPRTR register, and also sectoral databases where we retrieved site-specific data. So the coordinates were really important, which were part of the EPRTR database, but of course there are data gaps and we need to fill them, which was manual research, but we also have then company address and the greenhouse gas emissions. And for each site, we have listed the corresponding plants with information on the process, the production capacity, and also the age of the plant. Yes, here on the right, you can see the comparison of the production we have listed in the site database and national statistics, so the Prodcom. And there are not many deviations, and most of them we can explain. So quite high level of detail for these processes. For the quantification of the excess heat, it's of course based on several assumptions and different scenarios to capture also future developments. So for each process we have in the database, we define specific energy consumption values and excess heat factors that are based on the exhaust gas composition and the temperature level where the excess heat is recovered. And also this method is the base for the analysis of electrification hydrogen-based furnaces in the future, and then the new corresponding excess heat factors. In the end, we have excess heat potentials for 29 different processes in 1,600 sites. And at these sites, there are 2,600 plants from most of the, or from the energy intensive subsectors, so iron, steel, non-ferrous metals, glass and cement production, so non-metallic minerals, pulp and paper, the chemical and the refinery industry. For the matching with district heating areas, so we have point sources which represent the excess heat potentials, and then we analyze the distance to the district heating areas with different expansion levels of district heating. So we looked at the current situation and then at the future situation or expansion that could be possible of district heating, which makes the distance less. And in the case that district heating will expand. Here you can see on the right a screenshot of the map where different industrial sites are listed with the current and future district heating areas. So the future district heating areas are really quite ambitious. So all major city centers have district heating implemented. Yes, so the analysis is for the current status and different scenarios differed by the expansion of district heating, the temperature level decrease of district heating. So then we can quantify the effect on which temperature the excess heat is recovered at the industrial site. Then also we respect the efficiency progress in industrial processes and also transformation of industrial processes, so electrification and hydrogen-based furnaces, as I said. Also, part of the spatial matching is shown here is that we assume or that we incorporate a priority factor. So one excess heat facility can supply several district heating areas if they are small, and it's prioritized by the size of the district heating area. Okay, so then I come to the results. It's now quite a lot of information and data in the graphs. I'll try to explain them, but I will not focus on every number and every column here. So these are the results of the excess heat potentials depending on the technological progress shown by the different subsectors. So iron, steel, non-ferrous metals, consisting of aluminium mainly, pulp and paper, non-metallic minerals, and then refinery and chemical sector. And these different columns show then the effect of different industry scenarios, as I said. So first, this is the efficiency progress. So what happens if the industrial sites all employ best available technologies and maximum internal heat recovery, so it will be used on site. Then we have the blue column, and the step between the blue and the green column is the degrees in production quantity based on circularity and increase of secondary processes. So here in iron and steel, it's the case that we have a lot of secondary steel and not the reduction of iron to produce steel. And then from green to the next two columns, it's the implementation of low carbon processes, so electrified furnaces or hydrogen. So here it's the hydrogen shaft furnace for hydrogen for steel making. And the yellow is if really important base materials are imported. So for the chemical sector, it goes to 0 when it's assumed that methanol will be imported. But yeah, that's going into a lot of details. And what I want to show is that at 55 degrees, so quite low temperature heat recovery for district heating, we have found that we have 115 terawatt hours currently. It's reduced about half when we incorporate the efficiency progress to maximum levels. It goes further down to 47 terawatt hours with future projection, and for a transformed industry, it's 25 terawatt hours, so quite a drastic decrease of excess heat potentials. In general, the highest average industrial excess heat per site is found at refineries currently. So of course now refineries are a really interesting source of excess heat, but we have found also that it will decrease drastically in the future if they all transform to efficient and low carbon processes. And of course, it depends on the temperature level of heat recovery. So if we further decrease the temperatures in the district heating systems, the more energy we can recover and utilize in district heating systems, which leads me to the next slide. So here it's the utilization of the excess heat potentials in district heating systems. So it respects now the spatial matching to current and future district heating areas. And we can show that 35% of the available excess heat from industry could already be utilized by current district heating areas when we respect the distance and annual available heat. So that often if you have like a large industrial site, it's more than the district heating demand, which is close by. When district heating is expanded ambitiously, so it's the possible district heating here, so the orange columns, it increases the amount of excess heat that could be utilized, so it's 75% of the excess heat. So I inserted here the current level, you could say, of excess heat potentials for district heating. So it's conventional processes matched with current district heating areas. And if we look now, decreasing the temperatures to 25 degrees, which is really low, I know. But if you utilize the temperature, the excess heat at 25 degrees from transformed industries and expand district heating very ambitiously, you could compensate the excess heat decrease by the transformation, which I've shown in the last slide. In total, the industrial excess heat can contribute 1 to 8% of the total district heating demand. So all over Europe, when you look at the numbers, so it's a small part, but locally it can be a lot. Yes, that decrease can be compensated. Yes. What I want to show shortly here is a result validation. There are also other European-wide industrial excess heat estimations. Some of them are on country level, and what we have shown here is with other literature values, the deviation. So most of the deviations are larger than our estimations, so we are rather at the conservative approach to the excess heat as we look specifically at the processes and at the production quantity on net emissions and subsectoral level. Coming to the conclusions, yes, the industrial excess heat utilization for district heating depends on the level of transformation. Currently, we have a large potential. It will change. What we see is the largest potential currently is from refineries, from the steel production, and from the minerals. So cement and glass production. The energy efficiency progress in industry leads to about a 40% decrease of these industrial utilization potentials. And the transformation to low carbon processes is even more 20% decrease. So this is the lower limit, as I said, as it's a conservative approach. And we assume here a full transformation of industry. The expansion of district heating areas leads to the fact that most sites are located within 10 kilometers and even most of them within 2 kilometers of the industrial excess heat sites. And lower district heating system temperatures increase, then the heat that can be utilized by 30 to 170%, depending on the assumptions. And as I said before, the total contribution of the industrial excess heat to district heating demand is 1 to 8%. Shortly, the limitations of our study is that we don't look at the seasonal variation, so no seasonal mismatch between the demand and the supply. So you could say we assume a large seasonal storage. Other industries, so smaller processes, and also new processes like methanol synthesis, electrolysis are not in the scope. So there will be future excess heat potentials. And as I said, we are in a lower limit when we estimate the industrial excess heat utilization, the industrial excess heat, looking at the industry. Or the district heating expansion, we look at the upper limit. So this represents up to 45% market share of district heating for buildings demand. Yeah, to show what is possible. A short outlook, as I said, industrial excess heat is one pillar in the transformation, but it will not be the only one for a climate neutral district heating supply. Efficiency and expansion in district heating areas can compensate the possible decrease of the industrial excess heat potentials, but still there are other sources needed. Even though in individual networks or on local level, industrial excess heat can supply large shares or even completely. On annual level, the district heating demand. On country level, other sources will mainly supply the future district heating. And there I've shown a short outlook on 2050 with different sources that are suitable for a climate neutral district heating supply. And then that's it from my side. Thank you for your attention. And if you have questions, ask them now or later, if you feel like.